In this video, we'll be looking at function notation and then evaluating functions. Functions can be represented by equations or rules. The equation or the rule will generate ordered pairs. Okay. The equation will generate ordered pairs by taking the input that results in a certain output. Okay, and then the input and output values will be the numbers in your ordered pair. Okay, what we've seen before, all right, these are equivalent notations. Y equals 3x plus 2. And instead of writing it like that, instead of writing y, we're going to write f of x. That's why you say that, f of x. And this is function notation. Okay, so again, y is your output values. We're just now calling it f of x, the function of x. So whatever this output is depends on the input value that you put in for x. Okay, when it's written like this will give you ordered pairs in the form of x comma y. But when we change y to f of x, now we're going to have ordered pairs in the form of x comma f of x, the input value and its output value when you plug it into the function. Okay, so the value of x here is your input value. And when you substitute that value in here and then evaluate it, this number becomes your output value. So this just explains function notation. It's a way to name a function rule, making it clear which is the independent variable. All right, this is what the function notation looks like. Okay, and this is read as f of x equals x plus 2. Okay, so some function of x is equal to the x value plus 2. In order to evaluate a function, you simply substitute the input for the function's variable. So in this example, it says given the function f of x equals 3x minus 5. Okay, this is the function rule. We're going to take x values and we're going to substitute them in here to get certain y values or output values. Okay, so in this example, it says find f of 4. So f of 4, all I'm going to do is replace x with 4 in this rule, in this equation. 3 times 4 minus 5. So 4 was your input value, and now we're going to determine the output value by substituting that into the rule. So f of 4 is going to equal, well, 3 times 4 is 12 minus 5. And that means that f of 4 is going to equal 7, since 12 minus 5 is equal to 7. So here's how we interpret that. With an input value of 4, we get an output value of 7. Okay, so this means that the point 4 comma 7 is a solution to the function and would appear on the graph of the function. So again, this is your input value. This is the output value that you get when you substitute it into the function rule. F of 4 is equal to 7, meaning that 4 comma 7 is a solution to the function. In our next examples, we're going to evaluate the functions and we're going to state the solution as an ordered pair. Okay, so in each example, we have a given rule. So in this example, my function of x, so x is going to be my input, and to get the output, I'm going to do 2 times x plus 3. So whatever the x value is, I'm going to substitute that in here. I'm going to follow order of operations to evaluate it, to figure out the output value, and then I'm going to write my answer as an ordered pair. So again, the rule says f of x equals 2x plus 3. They want us to find f of 4. So f of 4 becomes 2 times 4 plus 3. And so now I'm going to multiply first. 2 times 4 is 8. And then when I add 3, this means that f of 4 is equal to 11. And so the solution here, the input value was 4, that's your x value, and your output value, the f of x value, it equals 11. All right, so the input value 4 maps to the output value 11. 4 comma 11 is the solution to this example. In letter B, this time it says g of x is equal to negative 3x plus 1. Okay, so instead of calling it f of x, now I've called it g of x. Okay, so it's the same idea. I'm going to take some input value, I'm going to substitute it in here to determine the output value, and I'm going to write my answer as an ordered pair. Here it says find g of 2. Well, g of 2 is going to become negative 3 times 2 plus 1. So if I multiply first, negative 3 times 2 is negative 6. And then if I add 1, g of 2 is negative 5. And so the solution written as an ordered pair, the input was 2, and it maps to an output of -5. So 2, -5 is the solution as an ordered pair. Our next function rule says f of x equals 2x minus 5. They want us to find f of 10. So 10 is our input. We'll substitute in here to determine the output. F of 10 becomes 2 times 10 minus 5. And then with order of operations, I'll multiply 2 by 10 in order to get 20. And then if I subtract 5, f of 10 is equal to 15. So the input is 10, the output is 15. 10 comma 15 is the solution in this example. In our next function, the rule says f of x equals x plus 8. Find f of 4. Well, f of 4 becomes 4 plus 8. Just substitute in the input for x. And that means f of 4 is equal to 12. So the solution this time is the point 4 comma 12. The input was 4, and it led to an output of 12. In our next function, f of n equals 3n. All right, so whatever n's value is, we substitute that in. It says find f of -2. F of -2 becomes 3 times -2. And so all we have to do is multiply 3 times -2 equals -6 for our output. So the solution here as an ordered pair would be -2, -6. Our next function rule, f of x equals 2x plus 5, find f of -3. F of -3 is going to become 2 times -3 plus 5. When we do the multiplication, f of -3 becomes -6 plus 5. And then when we add, f of -3 becomes -1. -6 plus 5 is -1. And so the ordered pair, the input was -3, the output was -1. -3, comma, -1. In our next function, f of h is equal to 5/10 times h minus 2. They want us to find f of 6. So this is the input value that we'll substitute in here. F of 6 is 5/10 times 6 minus 2. And then we'll multiply before we subtract. 5/10 times 6, or half of 6, is 3. And then when we subtract, 3 minus 2 is 1. All right, so f of 6 equals 1. So again, the input value is 6, and the output value is 1. So 6 comma 1 is the ordered pair. That's the solution. In our next function, f of p equals 8p plus 15. Find f of -7. So -7 is our input. F of -7 is 8 times -7 plus 15. And then when we do our multiplication, 8 times -7 is -56. And then if we add -56 and 15, we get -41. So f of -7 is -41. -7 comma -41 is the ordered pair that represents the solution here. Our next function rule says f of x equals 2x plus 15. Find f of -12. -12 is our input. So f of -12 equals 2 times -12 plus 15. We need to multiply. 2 and -12 makes -24. And then if we add, -24 plus 15 is -9. So -9 is our output, meaning that the solution here as an ordered pair would be -12 comma -9. An input of -12 led to an output of -9. Our next function, the rule says f of x equals -3x plus 8. They want us to find f of 1/2. So 1/2 is our input. F of 1/2 equals -3 times 1/2 plus 8. All right, well, we need to multiply first. -3 times 1/2 is just -3 halves. All right, and then we add 8 to that. And I need to do that addition, but I need to have a common denominator here. All right, 8 is the same as 8 over 1, which is the same as 16 over 2. So this is really -3 halves plus 16 over 2, and that is going to equal 13 halves as our output. So the ordered pair here would be 1/2 comma 13 halves. If you were to make these decimals, that would be the same as having 5/10 comma 6 and 5/10 as the ordered pair that represents the solution. In our next example, they want to know if the point -3 comma 8 is a solution to our function with the rule f of x equals -x plus 5. We're going to show work to support our answer. And in order to do this, it's important to remember that your x value here, this is your input, and it led to the output value found right here. So the input of -3 led to the output of 8. Would that happen if I used this input in this function right here? Okay, so what I'm going to do is try to figure out, is f of -3 equal to negative of -3 plus 5? And when I do that, am I going to get 8 as my answer? Okay, so f of -3 equals, well, the negative of -3, or -1 times -3, is +3 plus 5. And f of -3 then is equal to 8. So an input of -3 leads to an output here of 8. The function value of -3 leads to an output of -8. So that will give me the solution of the input -3 and the output of 8. -3 comma 8 is a solution in this example to the function. Okay, so what we're going to do is just take the input value, plug it into the rule, and see if that gives us the output that we're looking for. In our next example, the point that they give us is 2 comma 10. Is this a solution where the function rule says f of x equals 2x plus 4? So again, this is your input. Does it lead to this output? That's what we're trying to figure out. Okay, so f of x equals 2x plus 4. The input is 2. So we're finding f of 2. Well, that would be 2 times 2 plus 4. And if we do 2 times 2, that's 4. And then if we add 4 and 4, we get 8. So f of 2 equals 8, meaning the solution here would have an input of 2 and an output of 8. But they said 2 comma 10. That is not the same as what we have here. So 2 comma 10 is not a solution to the function. 2 comma 10 would not appear on a graph for this function rule. In our next function, we have the rule that says f of x equals 5x minus 16. They want us to find the value of f of 9 and state our answer, our solution, as an ordered pair. So our input value here is 9. We're going to substitute that in here and figure out the output. F of 9 equals 5 times 9 minus 16. And so the first thing we're going to do is multiply 5 and 9 to make 45. And then to figure out the value, the output value, we're going to do 45 minus 16, which is 29. Okay, so the input value was 9, and it gave us an output value of 29. So the solution is the point 9 comma 29.